Hi, welcome to our group's presentation. Well, have you ever wondered, will the sun rise tomorrow? Well, I have, and Laplace too. In the 18th century, the sunrise problem was first introduced by Pierre Simon Laplace, who treated it by means of his rule of succession. Talk a little bit about this guy. Laplace was born in 1749. He was a French scholar and polymath. Those work was very important to the development of a lot of fields such as engineering, mathematics, statistics, physics, astronomy, and philosophy. And Laplace is remembered as one of the greatest scientists of all time. Sometimes he is referred to as the French Newton. Back to the sunrise problem. People around him always assume that the sun will rise again no matter what. Laplace questioned against that, which is there a probability that the sun will not appear tomorrow? So he created a formula which called the rule of succession to calculate the probability that the sun will rise tomorrow. So, what exactly is the rule of succession? It is the formula for enumerative induction, which is reasoning from observed instances to unobserved ones. And the probability can be understood as the total of k plus 1 divided to the total of n plus 2, given that k is the possible observations out of the n total. So in his problem, which is the sunrise problem, he estimated that the sun has risen 10,000 times, so that he got the result that the probability that the sun will rise tomorrow is equal to 10,001 divided to 10,002, which is equal to nearly 99% that the sun will rise tomorrow. However, the most important point is how can he create that formula? We will explain that later. Stay tuned. See, the formula's application. Well, actually, we didn't see anything. So, here's our advice for you to use this formula in your daily life. First of all, you can calculate the probability that tomorrow will rain. Or you can calculate the probability that you will get a 10 in class. Or you can estimate the probability that your crush will like you. For example, if your crush said that he liked you 10 times, then he means that he liked you 91.6666% according to Laplace formula. So you should ask him about what is remaining 8.3%. Is it he give it to another girl?
Anyway, the most important point is how can Laplace create such a formula. We will explain this by looking at a similar example in which our main character is the coin, not the sun. And this is called Laplace coin flipping problem. It is described as follows. There are k plus 1 coins in a box, put in order from 0 to k. And when flipped, the coin in ith position will turn up head with property of I divided by k. For example, the 0th coin will have the property of 0 divided by k to turn up head. The first one will have property of 1 divided by k to turn up head, and similarly to the second, the third, to the kth coin. Now, if Laplace choose a random coin and flip it, if the n flips all result in head, what is the conditional probability that the n plus 1 flips will also be a head? Let's pause for a little bit to think about the problem before we jump into the solution. Alright, if you are still puzzling with the problem, let us explain it to you right now. For convenience, let con Ci the event that the coin in ith position is selected, and note that I begins with 0. Let Fn denote the event that the first n flips on result in heads, and finally let H denote the event that the n plus 1 flip is a head. So what we need to find is pH given Fn. And because a random coin is initially selected, we can consider pH given Fn is a total probability. This means that pH given Fn equals to the sum of probability of each coin to obtain the given condition. For example, if con C0 is initially selected, if we have the probability of PC0 to be selected, then it will turn up head with probability of PH given C0. And note that this coin is given that the first n flips on result in head. So we have to add given Fn to equation. And we do this similarly to con 1, con 2 to con k. And we sum these up and we have the following equation. Now let's calculate each part of this equation. For the first one, this is the conditional probability that we have learned in class. Now for the upper part, this is also a conditional probability that P of Ci Fn will be equal to P of Fn given Ci multiplied by P of Ci. And P of Fn given Ci, because each coin has the probability of I divided by k to be ahead, then n flips will result in I divided by k to the power of n to be ahead. And for probability of the coin in ith position to be selected, because each coin has the same chance to be selected, then there are k plus 1 coins in the box. Therefore, P of Ci will be equal to 1 divided by k plus 1. For the lower part, this is a total probability, and to calculate the probability of the first n flips on result in head, we have to calculate the probability of all of the coins to be result in heads. And this is pretty similar to the upper part, as we can see here. And note that these two are similar to each other, so we can delete them. For the second part, because each flip is independent to each other, hence with each coin selected, P of H given F and Ci will be equal to P of H given Ci, which is I divided by K. And if we take 1 multiplied by 2, we'll have the following formula. Up to this point, the equation can be shortened using integral approximation. But before we get into this, let's revisit the infamous Quatrail Vietnamese math integral. Do you still remember all of these? This is called integral, and by definition, it will be equal to this sum, which is called Riemann sum. The idea behind this is to calculate the area of this whole geometry by dividing into smaller parts. So if you still don't remember this, please check the description for more detailed explanation. So back to the main equation. If we assume that k is large enough to make the approximation, we can see that 1 divided by k is delta x, where I divided by k to the power of n plus 1 is fx, and by Riemann sum, we can approximate this to the integral of 0 to 1 of x to the power of n plus 1 dx. And this will be easily calculated to 1 divided by n plus 2. Similarly, we will have the lower part to be equal to 1 divided by n plus 1. And if we take these two together, we will have P of h given Fn will be equal to n plus 1 divided by n plus 2, which is what we need to find.